Chapter 7 Understanding Algorithms and Flowcharts. Learning Objectives. Understand algorithms and flowcharts. Identify symbols in flowcharts. Differentiate between algorithms and flowcharts. Write simple algorithms for problems. Computers perform a vast array of tasks, such as generating invoices, booking reservations, creating presentations, and even allowing us to play games. But how do they know what to do? They follow instructions provided by software programs, which are written in specific computer languages. A program is a set of instructions given to a computer to perform a particular task. Before writing a program, we need to plan how to solve the problem at hand. This process of planning uses tools known as programming tools, and two fundamental ones are algorithms and flowcharts. These tools help in creating effective and efficient software programs. Algorithm. An algorithm is a detailed sequence of steps or instructions designed to solve a specific problem. Key features of an algorithm. 1. The steps are arranged in a specific order. 2. The procedure has a clear endpoint. 3. Each step specifies a particular action. 4. The process aims to solve a particular problem. Example 1. Algorithm for preparing a cup of tea. Step 1. Boil water in a kettle. Step 2. Place a tea bag in a cup. Step 3. Pour the hot water into the cup. Step 4. Let the tea steep for 3-5 minutes. Step 5. Remove the tea bag and discard it. Step 6. Add sugar and milk as desired. Step 7. Stir the tea and serve hot. Similarly, an algorithm could also be written to list the steps required to solve a problem on a computer. Tidbit: algorithms are not just used in computer science, they are also found in various everyday processes such as cooking recipes, driving directions, and troubleshooting guides. Example 2. Algorithm for checking if a number is even or odd. Step 1. Start. Step 2. Input a number n. Step 3. Check if n is divisible by 2. If true, print n is even. Otherwise, print n is odd. Step 4. Stop. Flowcharts. A flowchart is a visual representation of the sequence of steps required to solve a problem. It uses various symbols to depict different types of actions and their sequence, which is indicated by connecting lines. Flowcharts are useful tools for planning and communicating the flow of a process, as they make the logic of the process clear and easy to follow. Symbols used in flowcharts. Flowcharts use standard symbols to represent different actions. 1. Oval start-stop represents the start and end points of a flowchart. 2. Rectangle process indicates a process or action, such as a calculation or data manipulation. Parallelogram input-output denotes input or output, such as data entry or display. 4. Diamond decision represents a decision point where a question is posed and the flow branches based on the answer. 5. Arrow flow line shows the direction of the flow of steps. 6. Circle connector used to connect different parts of a flowchart, especially when the flowchart is split across pages. Did you know flowcharts were popularized by Hermann Goldstein and John von Neumann, who used them for planning computer programs. Rules for creating flowcharts. When creating a flowchart, it is important to follow these guidelines. 1. Flow direction. Typically, flowcharts flow from top to bottom or left to right. 2. Start and stop symbols. Each flowchart should have one start and one stop symbol. Arrows. Use arrows to indicate the flow of data and control between steps. 4. Connectors. Use connectors to join different parts of a flowchart, ensuring continuity. Advantages of using flowcharts. Flowcharts offer several benefits, including 1. Flowcharts provide a clear and visual way to understand the sequence of steps in a process. 2. Flowcharts help in analyzing a problem by breaking it down into smaller manageable parts. 3. Flowcharts are useful tools for explaining complex processes in a simple and straightforward manner. Example 3. Flowchart to determine the greater number between two numbers. Flowchart. Algorithm. 1. Start. 2. Input two numbers, A and B. 3. Check if A, B. If true, print A is greater, otherwise print B is greater. 4. Stop. Example 4. Flowchart to add the first 10 natural numbers. Flowchart. Algorithm. 1. Start. 2. Initialize sum equals sign 0 and n equals sign 1. 3. Check if n equals sign 10. If yes, add n to sum, increment n by 1, and repeat step 3. If no, proceed to the next step. 4. Print the sum. 5. Stop. Difference between algorithm and flowchart. Algorithm, flowchart. A textual representation of the sequence of steps to solve a problem. A pictorial representation of an algorithm. It uses precise and specific language to describe the steps. It uses symbols and arrows to visually depict the flow of control and operations. Chapter Essentials. Computers follow instructions from programs. Programs are written in specific languages. Algorithms are sequences of steps to solve problems. Flowcharts visually represent these steps. Flowcharts use symbols like ovals, rectangles, and diamonds. Arrows in flowcharts show the sequence of actions. Algorithms can be written for daily tasks and mathematical problems. Flowcharts simplify understanding complex processes. Using algorithms and flowcharts helps in planning solutions. Flowcharts must have clear start and stop points.